Hi, good evening. How are you all? I hope I am audible. You can use the chat to interact, everyone. Good evening, everyone. Okay. How are you all doing? Yeah, Prableen, Ruturaj. Fine. Okay, great to know that you all are doing great. So, welcome to the today's session. So, let's start with it. So, you already know about the program. And quickly, I will highlight again the session hygiene rules, which we do in every session, that don't share any personal information, use the chat to interact and interact as much as possible so that it's a two-way communication, right? Keep a notebook and a pen with you so that you note down the important pointers and use your real name when you are joining the session so that we can interact with your real name, not your laptop names, right? So let's move forward. So the agenda for the today's session would be we would be doing a quick recap of what we have learned in the previous session. Then we would see what deep learning is. Then we will see what are neural networks. Then how AI sees and creates. And also we will do a lot of live demos, Q&A and quizzes, right? So let's move on to the first activity. Quickly take out your phones, scan the QR code, and once done, mention done in the chat. Everyone, scan the QR code fast. It will help me know that how much you are aware of and how we can go ahead in this session. So fill the form and once done, mention done in the chat. Okay, Prableen has filled. Everyone fast fill it up. Then we will move forward. Okay, done, Sanidhi, done. Okay, so as you are done, let's move forward. Okay, so we will recall what we have learned right now, till now. So we, in the previous session, what we saw was fundamentals of decision tree and the concepts of random forest. Also, we saw that how machine can help us recognize our personality traits, and we also saw a visualization of a decision tree. And we also built a model with no code using the orange demo application, right? So this is what we saw in the previous session, that was based on our choices and how we were answering different questions, we got to know that what kind of personality we have. And also, we was trying to build a decision tree with the prompt, but the site was not working. So as promised that we will see this in the next session. So I would be showing this. Give me a minute. I will share my whole screen so that it is visible. Okay. So we So this is, I have already created one. Reason being it was taking time to generate because we have lot of people in the session. So when we generate, so sites get heavy and it gets stuck sometimes. So this was what we discussed, that if I want to decide a weekend plan generator, how we can do that using the prompt. So it generated on my own. So first question was, how do you feel? So what is the root node here? Everyone be active on the chat. We discussed root node, leaf nodes, branches, right? So what is the root node here? Which is the root node here? How do you feel? How do you feel? Okay, great. Means you remember. Okay. So next choice, based on how do you feel? So my question is to you. How do you feel? How do you feel, everyone? Low energy, high energy, creative, hungry. Okay, I have got high energy, great, creative, also high energy. Okay, let's go for high energy. So if I have high energy, now what is this called as? Low energy, high energy, creative, and hungry. These questions are called as which nodes? Which nodes these questions are called as? Okay, KS Manu, decision nodes. Decision nodes. Sanidhi, decision node. Great. So you remember. So based on indoors, outdoors, I am an indoor person. So let's see. We have three options: gym, deep clean house, or escape room. Or in case I am an outdoor person, we can go for nature, hiking. We can go for city, street photography, or we can play tennis or basketball. That is how the we can generate or we can take help of machines to have our weekend plan, right? So let's move back to our PPT. This is what we have done already. Let me share my PPT again. Yes. So here we are. So this is what we have already discussed. Now, so I would be asking some questions based on what we have discussed. You would be answering the same in the chat. So first question is, which model is talking? I don't trust just one opinion. I ask multiple experts and take majority. Who am I? Decision tree, random forest, or logistic regression? Random forest in seconds. Great. Okay, Gayatri, Rituraj, Spooty, random forest. Okay, great. So let's see the answer. Yes, it is random forest when we go for the majority voting. We don't go for the single voting. Next one. Decision tree is best when dash is important. What is important? Speed, explanation, randomness, or GPU power? What is important? Gayatri says B, explanation. Okay, explanation. Shrusti says explanation. Okay, a lot of answers as B. So let's see the answer. So that is explanation. When we want easy explanation, we go for decision tree. Now, the next we have is, can you spot the algorithm? We have a rule in a school. If marks is greater than 90, scholarship. If marks is between 60 to 90, regular. Or if marks is less than 60, extra class is recommended. Which type of algorithm is this? Okay, Ruturaj, decision tree. Rest, Gayatri, B. Neha, okay, B. Okay, great. So I'm getting a lot of responses. So most of you are saying B, decision tree. That is correct. So that was what we have already done. So let's move further. Now we would be playing a challenge for you all. That would be a AI word decode challenge. So let's see who thinks fast. So what we will be doing, you will get 5 seconds mostly, and you have to think that if I have some letters mixed up, if you rearrange that letters, what word could be formed? So for an example, we will have 5 rounds for it. So for example, first round, what word could be formed from these letters? And that words to be related to ML and AI only. Which word could be formed? Okay, KS Manu, give me the answer. Okay, Spurti gave the answer. Ruturaj gave the answer. Okay, so let's see. That is root. So I have got the answers from KS Manu at the earliest. So great. So we will have 5 rounds for this. Next one, be ready in the chat. What can be formed from this? Okay. Dhruva, give me one answer. So let's see where Sanidhi. Neha, Srushti. Okay, a lot of answers. Let's see the answer to it. That is algorithm, right? So, without algorithm, AI is just a dream. So, let's move on to the third round. What can be formed from this? LOMED. Let's see who gives the answer first. Sanidhi. Great. Gayatri. Okay, so I have many answers. Sanidhi gave me the first one. So let's see. Yes, she is right. Model is the answer. The trained brain that makes the prediction behind AI. Now, the fourth round. Let's see who gives the answer to this. Shushti. Okay, I got the first answer from Shushti. That's correct. Sanidhi, Gayatri, Ruturaj. Harshita also gave the right answer. Shubham Yadav. Great, guys. So, right, so the answer to it is regression. You are right, where we are predicting the numbers like a pro. That is regression. So, we have the fifth one in front of you. What is this? What is the word behind this? Okay, I got the answer from Shrija first and a lot of answers following that from Dia, Harshita, Rituraj, Srushti. Okay, I have got 50 plus responses. So, Shrija was the one who gave first, that is data. No data, no AI, right? So, okay, so we have the final word now. Be attentive. What is this? What can be formed from this? Again, I have Sanidhi as the answer. Harshita gave me the first answer in this. Then Ruturaj, then Sanidhi, Gayatri, now a lot of people. So Harshita, kudos. That is right. That this is random forest. So one tree, many trees, forest stronger, right? So this is what we had today. So from node to root to model to regression to random forest, we just revised half of our machine learning in just 5 minutes, right? So your now AI brain level is unlocked. So let's move on to our topic for today. So my question from you all. If one tree makes mistake, will the entire forest fail? Yes or no? You all know that random forest is built up of many trees, many decision trees. But what if one decision tree fails? So will the entire forest fail? What do you think? Okay, I got yes, I got no also. Maybe yes. Okay. No, it won't fail because as we discussed already that what happens is we take the average of the decisions. If one is saying no and three are saying yes, we take the average of it. That is why random forest was stronger, right? So trees were smart, trees are smart, but what if problem becomes too complex? Too complex means right now in decision tree, how we were deciding? We were deciding if your marks is greater than 70, you are a topper. If between 50 to 70, you are average. Below 50, you are a under average category, right? So we were applying the conditions of if else, right? But if in some cases rules become impossible to write, so what happens in this case? In that case. So in that case, what happens is there is the introduction of deep learning in the picture. So how deep learning comes into play, wherein we are moving from rule-based thinking to brain-based thinking. Now we would not be making the rules, we would be taking into consideration the patterns. How? Let's see. So tell me, if you have seen a child around you in your society, in your home, how a 3-year-old child learns what a dog is. How you teach a 3-year old child that this is a dog? You might have seen in your neighborhood, in your homes, in your relatives. How do we teach them? Okay, by showing them, Shrushti says, right, by classifying physical features, Dhruva says. Okay, he has come multiple time across dogs and has registered that into the memory. Right. So what happens is I we show a child 100 pictures of dogs while he or she is watching a TV, or while we are moving around in the society. We show them that, see, this is a dog. We don't teach the rule to them. We don't say if fur and it barks and four legs, it's a dog. We don't say like this, right? What we do is we show them the pictures. We show them the real dogs, right? So what does child do? Child learns the patterns. Child is not based on the rules. So deep learning works in the similar way. Deep learning sees all of that, but as numbers. How? Let's move. For example, what is deep learning? Let's see first that it is a type of machine learning only. What we were doing till now, but it uses now artificial neural networks. And we will see in the further slides what neural network actually is. But my point here is how we teach a 3-year-old child by patterns. That is how deep learning works. It learns from the patterns automatically. We need not to define any rules. हमें कोई rules नहीं देने पड़ते कि आपके पास 75% attendance है, then you can sit. Otherwise, you don't sit. That were the rules which we were making till now. Here, it automatically learns. Machine खुद से सीख जाती है. So, moving to why our traditional programming was failing. Which is traditional programming? The Dhruva, right. Dhruva gave me a definition of deep learning. Right. It is a branch of machine learning that uses deep neural networks. Great. So, why traditional programming was failing? Means why we shifted from machine learning to deep learning. Anyone? Why we shifted from machine learning to deep learning? Okay, let's see. So if I tell you everyone that, okay, tell me that if I want to build a program to detect a dog, what rules you would write? Means if I want to detect that this image is a dog earlier by using decision tree, random forest, what rules you would write to detect it? What rules we can write? Rules as in if it has brown hair, it barks, how it looks. Right, Manu. Ruturaj, animal, snout, dog, right? So you are right. But in the scenario, for example, if you have a self-driving car, you all know that self-driving cars are very famous right now in the AI advancement. So do you think in the Indian traffic, you can teach a car to self-drive or to automatically gets into picture that what is going around? Do you think? No, no, no. Right, because in Indian traffic, we have bikes, autos, we have sudden pathways, we have many animals roaming around. So, how many conditions we will write? It's not possible in a practical sense, right? I cannot have a list of rules and I cannot feed that rules into the machine because that is not practical as per the real life scenario. So, what happens is traditional programming works when rules are clear, when rules are small, like in the school case, in the banks, in spam ham. So, in these cases, there were little amount of rules. We can define that. But in real world, the world is messy, right? Because I cannot teach a machine that if there is a crossing ahead, stop, or if there is some object ahead, stop, there is a divider, don't overtake. I can give some basic rules, but not all, because that changes with situations in real life. So that when data becomes too huge to train, that is when deep learning comes into picture. right? So when there are rules, manual programming is possible, we go with traditional, that is machine learning. But when we have a complexity, we go with deep learning. In that case, our manual programming fails. So let's move on to difference between machine learning and deep learning that we used to define the features in machine learning. It worked well on structured data. So my question from everyone, what is structured data? This you have learned in your first session. What is structured data? Any one example of it? Label data, okay. What else? Supervised data with labels, okay. Okay, so I am getting answers as label data, most of you. So struct Excel, Shalini says Excel, right. Sneha says unsupervised data. No, I'm not talking about unsupervised data. I'm talking about structured data. So structured data is when you have a structure of something like a Excel sheet. We have rows and columns, right? Like in the bank account, if you go in your bank passbook, that is structured, right? So whenever your data is structured, either in the row or columns, or if you go in the playlist, your playlist is structured. If you go on the mails, your mails are structured in your bank account, that is structured. Passbook details are structured, that is the structured data. But what about the data like images, like videos, like audios? That comes under your unstructured data, and that is why deep learning is into picture, to deal with the unstructured kind of data, right? So that was a major difference. Now how machine learning and deep learning works, we saw that till now अभी तक हम machine learning का जो मॉडल बना रहे थे, हम क्या कर रहे थे? We were giving data. It was, we were telling which features to take into consideration to check. Like for example, if we were checking to sit in the exam or not, we were checking the attendance, we were checking the project, we were checking the uh, assessment marks for the before the final examinations, and then we would be considering if the student will sit in the exam or not. So feature we were telling to the machine, and then we were training and getting the prediction, right? But what happens in deep learning? We just give the data to the machine, it automatically do everything. Which features to take into consideration, which parameters to train on, training, we simply get the output with the accuracy. This is the major highlight of deep learning. So this part which is being done in the machine learning, that we don't have to do in deep learning, that is automatically handled by deep learning models. Isn't that great? Okay, so before moving ahead, we would see that we would do one activity. So that how deep learning is more efficient than machine learning. So quickly scan this QR code. Then let's see something real, which we were discussing in theory because a lot of theory is done. So let's see something real. So let me also open this. Okay. So everyone is on this page. This is the image classification. Everyone has scanned? Mention done in the chat if you are done with the scanning part. Done, done, done. Okay, so if you remember the previous sessions, we did one activity of detecting a bird and a dog, in which the classification was only done that if the image we are entering is a dog or not, bird or not. That was the only thing. Now tell me something. If I show you one image, let's take one image from here. I will show that image also and the other one also. Let's take this image. You can take any image from the internet or your gallery and you can upload it. You can take any image from your gallery or the internet. You can go on Google, search a dog's image or a cat's image, and you can upload it. Okay, so it is analyzing. Now see here, analyzing image with ResNet 50. What is ResNet 50? It is one of the deep learning model on which this machine is trained. So that is ResNet 50. So, and you can see ResNet 50 has 1,000 classes, means it has 1,000 classifications already in the data set to classify on. So if I ask you, wait a minute, if I ask you that, let it run, let's see. It is loading. So you tell me, if I show you a dog picture, how many of you can instantly tell the breed? Not only dog or not, that everyone can tell, right? So how many of you can tell the breed of the dog? Mention in the chat. Okay, 10%. Okay, I can tell. Okay. Okay, Ruturaj says only the ones I know. Okay, so give me a minute. Let me share the whole screen. So you then tell me. Okay, so see, it has done. So now tell me. So what was the difference between the previous machine which we did, the practical we did in which we were only classifying dog or not? Here, now it is so accurate. It is not only classifying it is a dog, it is also telling which breed it is of, right? So see how accurate it is. Now this is the difference. Now how it has categorized into the breed also. Any idea? What features it might have taken into consideration? What do you think? Which features it has taken into consideration? 1 minute. Just a minute. Okay, now it's fine. So color pattern. Okay. Face, shape, color, pattern, body structure. Okay, Dhruva. Gayatri says fur color. Gayatri, dog lovers. Okay. So Sneha says shape. Okay, great. So you can see means you well recognize color, face shape, ear shape, fur length. But you are not just detecting dog, you are detecting the details of the dog subconsciously, right? So if I now change the picture, instead of, we will get back to this. Now if I change the picture, instead of this, I use some other picture of a dog like this. So, so if I change the picture, so now I have uploaded some other breed. So do you think it will be able to detect the breed? Yes or no? Do you think the machine will be able to detect the breed? Yes, yes, no. Okay, yes. Ruturat says yes. Harshita says yes. Okay. So by the time it is loading, now the here point is that we are subconsciously checking the texture, ear shape, and snout length, right? So how you did that in less than 1 second? You also figured it out, right? So if I give the same image to the traditional programming, how it would write? It would write the rule in the sense, if fur color is golden, ear type is floppy, nose length is medium, then golden retriever. If these image, then some other, then maybe a Pomerian or some other dog, right? But what happens if in an image a light changes or a background is yellow, if angle side is different, then the picture would change, right? So the color of the fur would also change. So that's the problem, right? So then how it would figure? Then at that time, traditional programming would fail. So now see, it is giving me golden retriever. as 95.1% as the answer. So see how accurate it is. So this is the difference, that how your deep learning models are more accurate than the machine learning models. We are not comparing, we are detecting features. It is basically remembering examples from the past. That is learning from the data. So now let's move on to the PPT again. Hope you are done with trying it with different examples. If you have done, mention done in the chat. Okay. Harshita, it should be trained on various examples. Done. Yes, it is trained on various examples. As I showed you, it is classified on 1,000 classes, not only dogs. If you put in any image, it would classify that. Either it is a fish, not only dog, a chair, table, laptop, anything. Because it has 1,000 classes. So your image should be among those 1,000 based on the features similarity. That is how it works. So instead of writing, so what is the beauty in it is that instead of giving rules to the machine, what we do, हम कंप्यूटर को 50,000 डॉग के इमेजेस दिखा देते हैं, राइट, विद डिफरेंट एंगल्स, डिफरेंट लाइटनिंग, डिफरेंट ब्रीथ्स. What happens? It starts learning from patterns. How we do to a 3-year-old child, we show different images so that it starts learning. The 3-year-old child, we don't teach him if and else, that if this is the condition, then this is this. It is automatically, a child is learning by the patterns. Similarly happens here, not rules, only the features itself. And these features, the model, deep learning model automatically detects. We are not training it. That is why deep learning is powerful, right? So now, important thing, in this machine, in this example, deep learning don't even know that this is a dog or not. It is only seeing the features, comparing the features and categorizing it. Now let's see how machines see the images. We are seeing it as a dog only as an image, as the we are recognizing the patterns. But how machine sees it? Model doesn't even know what a dog is. It only knows the numbers. Now how numbers? What do you see on the screen in this first image? What is this in the chat? What number do you see here? 8, 8, 8. Okay. We all see 8 instantly because our brain is trained to recognize the shape. That if the number is written in such a way, 2 rounds, that is 8, right? This is how humans see it. We see the full shape at once. We don't see dots, we don't see pixels, we don't use maths, right? Now, what is the second version? Now look at the middle one. In this image, this is the same 8, right? But now these small boxes is called as pixels. What is pixel? Have you clicked, have you clicked any image in your phone, and if have you ever checked the details of the image in your gallery ever? Have you checked the details of the image in your gallery? Yes. So do you see it is always stored in the pixels? How many pixels? 256 into 256, 175 into 300. Something is always written in the details, right? Gayatri checked, checked. Okay, a lot of people have checked it. So you know. So similarly, machine. So that is also how your image, your phone is remembering in the gallery. So now this tiny boxes is called as pixels, and now machine don't see this as the whole number, only see the tiny square boxes. And actually the third image is how a computer actually sees it, not as a shape but as numbers. Means 0 means light pixels and 1 means dark pixels. Now if I scroll over this, if you join 1, it makes the shape of 8, right? Can you see it? If we join 1, 1, 1, it makes 8. If you can see, mention yes in the chat. Yes? So that is how. Now what machine is looking, as you recognize that this is a pattern, right? This is a pattern. If this pattern is followed, then this image is a 8 digit. So for a machine, this 8 is a pattern of just 0 and 1s. So when I say AI recognizes handwriting. It is not seeing 8, it is calculating patterns of numbers. Okay, now I ask you one question. If I change one pixel, will the machine still think it is 8? If I change one pixel, will the machine still think it is 8? What do you think? Gayatri says maybe. Yes, yes, okay. Ideally, it should. Okay, Rituraj. Sneha says no, maybe. Okay, so I have a mix of replies. So, see, if too many pixels change, it might think it's 3. But it is possible if one pixel change, if one is not here, it might not change the number. But if more pixels change, it might think it is 3, it is 5. That is why we say data quality matters. That is why we go to a photo studio, they say photo quality matters. Why? That is because if we do give that into the machine, the data qualities matters because that is changed into the pixels. Right? So when you saw 8, did you calculate zeros and ones? No. We just saw the patterns. So what if we build a machine system which is inspired by the human brain? And that idea is called as neural network, because how we saw the 8 is by our tiny processing units as per our brain. That our brain recognizes this 8 as an image. Our brain, neurons in our brain, they work together to recognize the patterns. Similarly, what scientists did, they made a machine inspired by the human brain, and that machine is called as your neural network. Isn't that amazing that we have now a machine that is similar to our brain? So if this is the human brain, you might have seen this image in the elementary school, that this is the dendrites, we have nucleus, we have axon, we have this roots. Now what happens? Suppose we touch a hot object. Now this dendrites gives us the signal, nervous system gives us the signal, axon processes it, and in response we remove our hand. That is how the neurons of the brain works, right? Does that happen with everyone? If you touch something and it is hot, we remove our hand. That is our instant reaction, right? Okay, that happens. So similarly, your artificial inspiration is we give different inputs. This is our neuron, and here multiple mathematical calculations are done, computations are done, feature pattern recognition is done, and we finally get the output. So this is similar to our neural network, right? So now let's see the layers of the neural network. So we have 3 layers in the neural network. First is the input layer, wherein we are giving the images, right? And those images are converted at the backend by itself in the pixels. Second is the hidden layer, where the most magic occurs, where the machine detects the edges, as you mentioned, fur, color, bark, or the, you can say, nose length or the nose shape, structure, detect the curves and the patterns. That is done in the hidden layer. And finally, we have the output layer, which gives us the final classification or the final answer. So this is how our neural network works. The structure says input layer, which receives the data and passes it to the network. Second, we have hidden layers, multiple layers that extract and transform the features. And then we have output layer, which gives us the predictions. Okay, so let's see on the screen. Enough of theory now. Let's move on to the next thing. What do you see on the screen in the left image? In this image, not asking about the right image where my mouse cursor is moving. In this image, what you see? Mention in the chat. Which objects you see here? Okay, Rituraj says laptop, phone, teacup, mouse. Okay, great. Harshita, laptop, phone, mouse, cup. Laptop, mobile, cup, mouse. Okay. Okay. I can see Gayatri saying laptop, phone, mouse, cup, saucer. Okay, great. Okay, when you saw this, did you look at the entire image at once? Or did your brain scan and separate the objects? Did you look at the entire object at once or did you separate the objects? What did you do? Harshita says separate the objects. Okay, separate. Gayatri says separate the objects. Separate the objects. Okay. So what our brain did? It identified the boundaries, it recognized the shapes, separate the objects, and we classified each one in milliseconds, not even seconds, right? In milliseconds. And in the previous example of the dog, what we were doing? AI said dog. That was a single label. Now here, what AI should do? AI should find where actually object is, identify what object it is. That's more complex, right? Is it complex than the previous one? Earlier, we were only categorizing a single image. Is it complex than the previous one? Yes or no? Okay, a lot of yeses. Okay, so if I say that AI says only laptop, is that enough? If I put this image into the AI and it says only laptop, is that enough? Okay, Ruturaj says no, no, no. Okay, KS Manu says no. Okay, because where is laptop? I need to know that also, right? What if I want to draw a box around it? That's detection. So if I hide one object mentally, if I remove mouse from here, does scene still make sense? Yes. But what if I remove laptop from here? See, the whole image changes strongly, right? So which object is more important here? Which object is in which boundary? That detection we can do in milliseconds. But what if I have 1 lakh images? Can I do that? Is it possible? What if I have 1 lakh images? Can I do that? No, that's not possible, right? So AI can do that if it is trained on multiple objects. So the earlier example which we were doing, labeling one whole image, that is image classification. We were classifying the image. And now we would be seeing how we detect a object. That is how multiple objects can be detected. So let's see, scan this QR code, scan this QR code and we will see how objects are detected. Let me open also. Everyone on this page? If yes, mention yes. So it is same. Now the model used here is YOLO. Now YOLO. Now I would take any image. Let's take the right image. First, let's take the image we were categorizing. Then we will see. It will upload. It's uploading. So let's see if it can detect the objects. Everybody has scanned it. Everybody on the same page. Okay. So see, it has done the detection. It has found out 4 objects, 5 regions. So it is loading. Let it load. Yes. So you can download any image, or if you are sitting somewhere, you can click your recent image. You would be having multiple objects around you. Laptop, mouse, a pen, paper, a water bottle, a lot of things. So you can click a real image and upload it. So it's taking time to load. By the time it is loading, okay, let's see. Let me refresh it. Okay, if you are done, mention done in the chat if it's working for you. So what happens is we all use the same site and we start uploading the images. So it gets slowed down, but it will work. It won't stop like the previous session. Give it a minute. Okay, I have refreshed it, I guess. Let me upload the image again. Okay. Sanidhi, done. Great. So did your machine able to detect the objects? Okay, so let me stop sharing. My other tab has worked. So let me share the entire screen. Okay. So you can see my screen, right? So see, I have uploaded the right image which was there on the PPT. So see, it has identified 8 objects. Now 8 objects, if I zoom, it was so messy. Then also it has categorized that this is the bird. It has made a boundary. And the 0.89 is the probability, prediction percentage, how much percent correct it is bird. Then we have dog, bird, cat, right? So, and also if I go on to the segmentation part, it has highlighted the segments also. The small images also is being, even our fish bowl is being identified, which we might have skipped if we have done by our eyes. So see how accurate your deep, now this is purely deep learning. Now this is also loaded. So this is what we recognized: mouse, cell phone, cup, laptop. And it has defined the boundaries also. So this was the object detection. Done, everyone? Mention done in the chat if it's worked. Okay, most. Okay, done. Okay, most, not almost. Yeah, it might skip one or two, but most of the major chunk of your objects in the image, which is the majority part, will be highlighted, right? So it is inspired by the brain. It is detecting the features, not only learning from the rules. Now we have been saying till now neural network, but now the official name of neural network is artificial neural network. Now why artificial? It is same. We give the input, we have layers, and we get the output, right? Why artificial? Answer in the chat. Why it is called artificial? I can see everyone has done the activity. Let's move on to this now. Why this neural network is called as artificial? Because its official name is artificial neural network, that is ANN. Okay, it mimics the brain. I got one answer. Okay. Okay, right. So basically it is inspired by the brain but built using the math. So it is not man-made. So that is why it is called as artificial. So it doesn't think like humans. It calculates like a machine, but its structure is like a human neuron. So basically what ANN is, it is a network of artificial neurons which is connected together, which is learning the patterns from the data, right? So tell me one thing now. When we go to school, do you start reading books from kindergarten itself? When you go to the school, do you start reading books from the kindergarten itself? No, no, no. Right. So what we do is we learn the alphabets, that is the foundation. Then we go to the words. Then we learn the sentences. Then we Dhruva right alphabets. Then we go to the meaning. That is how is the hierarchy we follow. Right. We cannot understand a book without learning the letters first. So that is called as your layered learning. So that happens in your deep learning also. That what makes deep learning deep is the multiple layering we have in the deep learning and automatic feature learning. As I said, we don't need to define the feature, it automatically learns. In as we saw in the machine, we nowhere mentioned that this is a dog, now tell me the breed. It automatically learned the patterns and it mentioned the breed, right? So similarly, we only give the raw data. We have n number of layers in between. That is why, and this multiple, due to this multiple hidden layers, it is called as deep learning, right? So let's see that when to use deep learning is when we have the complex data, as we discussed, like image, audio processing, when we are doing like in Siri or in um, when we are using a Google voice. So in speech recognition, we use deep learning models. In voice assistants, in voice chatbots, we have deep learning models. In video analysis, when we have gaming videos or something, in that also, action recognition, we have deep learning models. And also in the natural language processing. This you will study in the depth in the next session. But there also we have deep learning models like in the chatbot, in ChatGPT. So how ChatGPT is understanding our language? By natural language processing models at the backend. Now, what applications we have of it? We can do image classification as we did. We can do object detection. Now, how object detection is useful? Have you seen the reels or the ads around that now we have the traffic lights, which is so much advanced that if a person standing behind the white bars, if not wearing the helmet, the green light is not shown. Have you seen that ad? Okay. Yes, yes, yes. Some says Nisha says yes, Anidhi yes. Some says no also. Okay. Go and search for the smart traffic lights. Now some traffic lights are so advanced if they have the computer vision in it. If the person is not, it is not in India so much, but it is in abroad that if the person is not wearing helmet, it does not turn to green. That is how advanced technology. So their object detection comes into picture. In road, if we have to train a self-driving cars, we can train it by object detection, that which is a car, which is a dog, which is an animal, which is a person, which is a, you can say, footpath, which is a traffic light. That is stored by object detection or deep learning models in the self-driving cars. Similarly, your speech recognition, this we have already discussed. Now let's move on to the tools and frameworks. We have TensorFlow, PyTorch, Keras. I'm not going into the depth of the technical. Let's see the practical of it. Scan this. We will see the practical of it. That actually how our neurons or machines at the back end is working. Let me open it. Okay. So everybody has scanned. Now everybody is on this. This is your TensorFlow playground. Everybody is on this page. If yes, mention done in the chat. Okay, a lot of yeses I can see. Great. So this is a simple neural network, right? In which I have four types of data. If I change the data, you can see the data is being changed at the right. Now this is my features, the input. Right now only X1, two features are selected. You can change that by clicking on it. Now these are your neurons. Now here I have only one hidden layer for now, two hidden layers, this and this. This is my output. Right now only two hidden layers. I can increase or decrease the neurons also. I can increase or decrease the neurons also. We'll see what this is. Now this is the play button herein. What is epoch? Written here, epoch is number of times we are sending our data into the machine, and the number of times increases. वो उतना ज्यादा क्या करता है, सीखता जाता है. फॉर एग्जाम्पल इफ आई शो अ 3 year चाइल्ड अ डॉग फर्स्ट टाइम, वो कुछ पैटर्न्स याद रखेगा, उसके बाद हम वापस से इमेज दिखाएंगे, वो कुछ पैटर्न्स और याद रखेगा, राइट. बट इफ वी विल शो देम कंटिन्यूअसली फॉर 10 days, इट विल रिमेंबर, वो ट्रेंड हो जाएगा. Similarly, epoch is number of times your data is sent into the model. So if I run it, see how your categorization is done. You can see the difference. Right now is the simple. It is blue classes are separated and orange are separated. Now, what if I change the data? Now, here it is a messed up. Now, let's see. Only 95 epochs, it is separated. Now, what if we have this kind of data? Now, let's see. So, it will take a lot of time to classify this data. But in this case, what we can do? Let's try increasing the hidden layer. Now I have introduced 4 hidden layers in this. 4 hidden layers, and let's now let's increase the neurons also. Let's see. Now we will start it. Now see what happens. And you can see one graph also here. What is this graph basically? That telling your loss. Loss means error. Now your error is decreasing for now. See, it is being classified. Classified धीरे धीरे हो रहा है. It takes time because it is the most messy data. It has to classify at different levels. So see how it is being classified. It is still working, still working. And when you won't stop, it will classify in a way that your these points are in orange. See how beautiful it is that orange points are classified so briefly. Kitni slight, there is no slight difference also in the blue and orange. Proper boundary is made. How it is fluctuating. So this is what happens at the back end of your neural network in reality also. And there are things you can see here. What is the learning rate? At which speed your model is learning. That is your learning rate. And what is activation function basically? What is activation function? If we are hungry, what we do is we eat food and we get active, right? So activation function decide which neurons should be active or which neurons should be dead. That is what activation function do. And we have different activation functions here we can choose with. That is up to us. So if I stop now, you can see how accurately it has created the boundaries for the blue and the orange classes with so much of complex data, right? So that is how deep learning is so accurate, and this is how your neurons at the back end is working. Now, if I hover over any neuron, it will show that ये neuron क्या classify कर रहा है और कितना classify कर रहा है. Now, every neuron has its own contribution towards till the end. And you can see every layer is interconnected with the next and the previous layer. That is how at the back end your neural network works. So what you can do is play around this on the side, check with different hidden layers, increase and decrease the neurons in each layer, and check with 4 kinds of data you have. This is the spiral one, and you have different data. Check with it, increase, decrease the training ratio, training testing ratio, and see how it is working at the back end, right? So let's move on back to our slide. Here, let me open the slide from here. Okay, let me share the screen. Okay, so we were here. Now, the last thing of our session is the last quiz, last activity. So on your screen, we have the QR code. Scan the QR code, fill out the form so that I know that you have learned about deep learning. You know what neural networks are, how your brain is functioning. So fill out the form, and once done, mention done in the chat. Everyone, scan the QR code. Once done, mention done in the chat. Okay, Sanidhi has done. Rest of you, buckle up. Spooty done. Nishta done. Okay, I can see a lot of done now. Okay, so all of you, hope all of you have filled out the form. Let's move on to the last part, that is conclusion. So in this session, what we explored that how machines move beyond our rule-based logic, and we have begin with learning patterns like human brain. right? So we saw that how deep learning is different from machine learning, how our neural networks is inspired by the brain, and how AI recognizes image classification and object detection, and what is the difference between both, and how your neural networks or machines are helping us in real world problems like self-driven cars or traffic detection in such problems, right? So we are open for the questions. If you have any questions, you can ask in the chat. If you have any questions, you can ask in the chat. Okay. Okay, so ending with it. So last question from my end, if you have no question. So what do you think? AI is scary or AI is understandable? AI is scary or AI is understandable? Nisha, understandable. Spooty, understandable. Understandable. Manu, okay. So it's understandable to everyone. Great. Okay. So let me stop sharing the screen. Okay. So Manu, you can refer to the LMS for the same, right? Okay, everyone. Thank you. Bye bye. Have a nice evening. We'll see you in the next session. Goodbye.